If you're running a CO2 laser, you're probably pretty good at making beautiful, personalized items that sell for, maybe up to 85 bucks. But what if you could tap into a market that doesn't just want something pretty, but demands permanence? I'm talking about a market where jobs for tool marking, firearm serialization, and medical parts, well, they start at $150, $300, and can climb past $500. Today, we're going to dig into the Fibre laser, the machine that unlocks all this industrial-grade work and a return on investment that is, well, it's genuinely staggering. Okay, let's dive right into this. The key thing to get here is that this isn't just about an equipment upgrade. This is a fundamental leap in your business strategy. We're talking about moving out of that high-volume, lower-margin world of consumer crafts and into the realm of high-stakes industrial contracts. The profit potential here isn't just a little bit better, it's in a completely different league. And this slide right here just perfectly captures that core difference. See, the consumer market, which is really the sweet spot for CO2 lasers, it values aesthetics, things that are pretty and personal. But the industrial market? They pay a massive premium for marks that are permanent and functional. We're talking about things like part traceability in an aerospace supply chain or unique device identification on a surgical tool. This isn't about decoration. It's about compliance. It's about liability, and it's about durability. It is absolutely essential. So what is it about a Fibre laser that makes it the right tool for this kind of job? Why can it do what a CO2 laser just can't? Well, it all comes down to the core physics of the machine. Let's break down the technology that makes it so incredibly effective on the metals and plastics that these industrial clients build their entire businesses on. Now, what's really fascinating about the slide is the wavelength. A Fibre laser operates at 1064 nanometers. That wavelength is 10 times smaller than a CO2 laser's. So why is this the magic number? It's because this specific wavelength carries energy that is just readily absorbed by metals. It gets the electrons on the material's surface all excited, allowing it to create a permanent mark. A CO2's much longer wavelength, on the other hand, just gets reflected right off the surface of bare metal. It's just fundamentally the wrong tool for the job. All right, so let's see how this powerful technology actually translates into two primary and very profitable techniques. You see, it's not just about making a mark. It's about delivering the exact type of mark an industrial application demands, whether that's for a simple visual ID or for non-negotiable legal compliance. First up is surface marking. This is an incredibly fast process that uses lower power at a very high speed. It doesn't actually remove any material. Instead, the laser's energy creates a thermal reaction right on the surface of the metal, forming this permanent, high-contrast black mark. This is the go-to method for logos, part numbers, and labeling medical tools, where you need absolute permanence without changing the surface texture at all. Then you've got deep engraving. Now, this is a completely different game. Here, we're using high power, slow speeds, and usually multiple passes to physically vaporize and blast away the metal, carving a mark that has real, tangible depth. And the crucial point here is, for some jobs, this isn't a stylistic choice. It's a non-negotiable legal requirement. Think about firearm serialization, where the ATF actually mandates a mark of a specific depth. This is where a Fibre laser opens doors to incredibly lucrative work that's just impossible to get any other way. So this level of capability is really impressive. But let's shift gears for a minute and talk business. Does the higher upfront cost of a Fibre laser actually make financial sense? Let's put the romanticism of the tech aside and just look at the hard numbers on the return on investment. And wow, these numbers really do tell the story. Let's be conservative. Let's say you're only working 12 hours a week. With a $3,000 CO2 laser, you might average, say, $35 an hour, generating about $21,000 a year. Okay? Now, with an $8,000 Fibre laser, your average hourly rate can easily jump to 85 bucks or more. That same 12 hours of work per week, it now brings in over $53,000. That's more than double the revenue for the exact same amount of your time. So, the crucial point is this. Even though the Fibre laser costs more upfront, that massive leap in earning potential means the machine pays for itself completely in just 5 months. After that, that huge difference in revenue becomes pure profit. It's honestly one of the clearest and fastest returns on investment you can find in this entire industry. Understanding the tech and the ROI, that's half the battle. The other half is adopting the mindset that goes with it. To really capture this industrial market, you have to evolve from being just an operator into a professional, totally reliable solutions provider. And this is the key insight right here. Industrial clients, they aren't buying a one-off creative project. They are buying certainty. They're paying for reliability and for perfect repeatability every single time. Having the technical discipline to create standardized, documented processes, that's what minimizes your errors, builds unwavering client trust, and proves to customers and potential investors that your business is a stable professional partner. So, we'll leave you with this question to think about for your own operation. Take a good look at the industries around you: manufacturing, medical, aerospace, automotive, and just ask yourself, where does a critical need for a permanent, functional mark create an opportunity for you to deliver incredible value? Thanks so much for watching this explainer.